Hi everyone. In this project, we're studying the impact of data on LLM fine-tuning. This is Rishabh, Sakshi, and Yash. So, for the introduction, language models are transforming machine learning, but they pose a significant alignment challenge. Alignment in LLMs aims to enhance model safety and helpfulness, particularly addressing issues of toxicity and truthfulness. There lies a challenge in fine-tuning these large pre-trained models for human interaction while maintaining safety. So, what are these challenges in alignment? LLMs trained on these vast textual data may exhibit toxicity and unsafe behavior. And also, these alignment processes involve reconfiguring models using demonstration and comparison data. So this brings us to the motivation. Firstly, LLMs are witnessing widespread adoption due to their capability in complex reasoning. The alignment step in particular is critical for making LLM safe and appropriate for human interaction. And in this project, we are aiming to understand and improve this alignment process, particularly addressing safety concerns. There's also the issue of cost and reproducibility, in which this alignment involves significant cost and human annotations. And this lack of reproducibility and limited studies hinder the AI alignment research. Which leads us to the objective, which is that the project aims to investigate the influence of diverse demonstration and comparison datasets on the fine-tuning of LLMs. This brings us to the methods. For the methods, we've utilized the Transformer Reinforcement Learning Library, which is the TRL library for fine-tuning. This library covers supervised fine-tuning, SFT, reward modeling, and direct preference optimization, DPO. And for the model, we've chosen Meta's Llama 27B model for experiments. This is because it has a strong open source LLM. Um, and we've also applied the LoRa technique that was learned in the class for its computational efficiency. And we've trained it on a single GPU. We had a question of whether to use DPO or RLHF for the next step of fine tuning. And we've selected DPO over RLHF for stability and efficiency.
As for evaluation, we've decided to use the Eleuther AI benchmarks. We've leveraged the Eleuther AI benchmark specifically because it's a comprehensive, it contains like a various set of common sense reasoning benchmarks that cover a wide range of tasks and domains like Arc Challenge, Pika, HELASWAG, and MMLU. As for the safety benchmarks, we've used Truthful QA and Toxygen to evaluate on truthfulness and toxicity, respectively. For the safety score computation, we've computed safety scores for different demographic groups, as was proposed in Hosseini et al. We've used scaled perplexity, which is a metric that combines language models perplexity with the toxicity scores. So this means that a higher score would indicate a safer language model because these models will prioritize harm avoidance in diverse contexts. For the data set, we've used four of them for experiments. We've used SHP, which is the Stanford Human Preference data set, LIMA, which is the less is more for alignment data set, HHRLHF, and ORCA. So the Stanford Human Preference and LIMA are human-generated data sets. SHP was gathered from Reddit based on upvotes and has 385,000 instances. It focuses on human preferences and helpfulness. As opposed to this, LIMA has a slightly superior strategy where it uses a well-curated human data set with 1,000 prompts and responses, and this curation is done specifically for fine-tuning benefits by humans. HHRLHF is a comparison data set with 91,000 human preference records per alignment, and this was chosen due to its scale and diversity. And ORCA was chosen because it specifically was generated for alignment and safety improvements, and this is like a large-scale LLM-generated data set with approximately 1 million GPT-4 completions and 3.2 million GPT-3.5 completions, and from this, we've sampled about 100K points.
So basically, we have two type of data sets. One is human generated, other is LLM generated, and we are doing two step of fine tuning. One is SFT, supervised fine tuning, followed by DPO fine tuning. So in this slide, we are going through DPO SFT fine tuning and DPO fine tuning when done on human generated dataset, which is SHP. So we observe when we do SFT on SHP, we see a decline in common sense reasoning with no safety improvement. Our hypothesis here is that upward based prioritization in SHP dataset led to suboptimal results. Further, when we do DPO on the same dataset, we see further drop in reasoning and very slight improvement in safety. Our hypothesis there is that DPO on SHP dataset is less impactful due to suboptimal curation. Whereas when we do the same SFT on LIMA, which is a very well curated data set, we see clear gain and not clear gain in reasoning, while a further increase in truthful QA. So this highlights a careful curation in LIMA outperforms poorly curated large SHP dataset. On the contrary, when we do the same steps on LLM generated dataset, there we see that when we do SFT on ORCA dataset, we see clear reasoning improvement and truthful QA boost. But the improvements are on the same scale as LIMA dataset, highlighting that a well-curated 1,000 LIMA points can match the performances of 100K LLM generated dataset, which just highlights how important it is to curate dataset for SFT. Further, when we do DPO on RLHF Anthropic dataset, there we see the models outperformed on safety and competitive reasoning. So this highlights DP on RLHF dataset is more impactful due to careful curation. Further, we do a different demographic comparisons. There we see that performance trend match what we observed in toxygen performances. Parallelly, RLHF models showcase significant performance improvements here also. An interesting point to note is that toxygen performance moved very little in the previous table, but here you see different demographics showing different variations in them, which just highlights that the different demographics should be studied. And we further see that certain demographics like women and Muslims show higher fluctuation than other demographics, which just highlights that these different data sets on which we are fine-tuning have some form of impact on how different demographic safety scores gets impacted, which requires a future detailed study to be done. Finally, data curation matters, which is evident here also for different demographic groups. So in conclusion, data curation matters, which we observed again and again in LIMA and Anthropic HHRLHF dataset. And it is important to have a dataset which can lead to a safer model, at the same time having a very helpful model, basically have good common sense reasoning performance with improvement on toxicity and truthful benchmarks. Further, there is a play of human curated and LLM generated dataset, with both of which can contribute to fine tuning stages. And the basic premises that you want it to be very well curated.